Now, the next part of the question says, using the result from 1a and b on page 12, that's the previous result, show that sine squared theta plus cos squared theta is equal to 1. Alright, I had put the previous answer up here to make space. So this is not referred to as sine theta squared. It's really sine squared theta. Now, we had sine, in working this out, we had sine theta square, sine squared theta. Well, we had sine theta and cos theta. So remember what they were. It was a case where we had sine theta A over B. Let me rewrite that. Make some space between the sine theta. Sine theta is A over B. Theta is this. Opposite over hypotenuse. Or A over C, I mean. A over C. Cos theta is adjacent B over hypotenuse C, B over C. Alright? Now, you need to show that when we square this and square this and add them, you get 1. So let's see what happens. Sine squared theta is A over C all squared plus cos squared theta is B over C all squared. Now that turns out to be A squared over C squared, because if you separate them, A over C all squared is the same as A squared over C squared plus B over C is all squared is the same as B squared over C squared. Right? Now, in this case, you have A squared, continue down here, A squared plus B squared over C squared. Now let's look at the answer to part A. Part A said A squared plus B squared is C squared. C squared is A squared plus B squared. So basically, it is saying that all of this up here, right, is C squared. You can see it from this. A squared plus B squared is C squared. So this becomes C squared over C squared. But what is C squared over C squared? It has to be 1. Number divided by itself is 1. So therefore, what this is showing is that sine squared theta plus cos squared theta is equal to 1, shown. Alright.